Okay, so in this second part of lesson 5.1, so just to make it clear again, this is still 5.1 second part. Let's go over more examples on how to establish the initial simplex tableau and how to perform the pivoting operation. So immediately after that, when we move on to 5.2, we will focus on how to choose the pivot and how to figure out when we reach the solution, if that solution exists. So I'm going to start actually 5.2 by showing you step by step what the algorithm does in an example that can be actually solved graphically, just to see what the algorithm does. And then after that, we won't use the graphical method anymore. So let's do the first example. Let's suppose that you need to maximize the objective function p equals 2x1 plus x2 plus 3x3, subject to the constraints given by 5x1 plus 2x2 plus x3 less than or equal to 20, 6x1 minus x2 plus 4x3 less than or equal to 24, and finally x1 plus x2 plus 4x3 less than or equal to 16, and all variables positive. So remember to check to see if the problem is in the standard form. So remember, standard form means constraints are less than positive numbers, and then all variables are positive. If the inequalities are not in the right order, like not less than something, multiply by a negative and then check again to see if the right hand side is positive. So less than positive, both this condition needs to be satisfied. And remember, we're going to focus just on the standard problem, both for the maximum and the minimum problem. So for now, we're looking at the maximization problem. So the first step is to introduce slack variables. You're going to need as many slack variables as the number of inequalities, because these, remember, the meaning of these slack variables means that you need to add something on the left side to change the system into a system of equalities, and then move x1, x2, x3 on the left in the p equation, in the equation for the objective function. And you're going to write that at the end. So the entire problem then becomes 5x1 plus 2x2 plus x3 plus s1 equals 20, 6x1 minus x2 plus 4x3 plus s2 equals 24, and x1 plus x2 plus 4x3 plus the third slack variable s3 equals 16. And pay attention here to the objective function moving to the left. Everything, we're going to get p minus 2x1 minus x2 minus 3x3 equals 0. With a little practice, you can introduce the matrix, the augmented matrix or the initial simplex tableau right away, starting from the initial system of inequalities. But until you get used to that, to do it quickly, then just go through all these intermediate steps. So remember that there are several columns in this matrix, the so-called basic variables, which you're going to fill in later, and then p, x1, x2, x3, s1, s2, s3, and the right hand side of the entire system. It's very important to write these in this order so that you can follow through with the algorithm in the correct way. You can draw a line over here and then another two vertical ones so you can separate the basic variables on the right hand side. These are going to be optional later, but for now stick to this rule. And by column, you're going to write the coefficients of each of these variables from top to bottom. You always end up with 0 in the beginning for P. In fact, the column for P will be always like that, 0, 0, 0, 1, because there's no P in the first three equations and there's just P on the last equation. Make sure you don't mismatch the coefficients. We're looking at x1. The coefficients are 5, 6, 1, and minus 2. For 2, we get 2, minus 1, 1, and minus 1. And then for x3, we have 1, 4, 4 again, and minus 3. And the slack variables in the beginning will be columns of the identity matrix by default, because this one appears in the first equation, so that means coefficient is 1, but it doesn't appear in the other three equations. S2 appears only in the second, S3 only in the third equation. Finally, the right hand side is 20, 24, 16, and 0. So another practical matter to do in the beginning is to isolate also the last row, because the last row will be important for later to read how we choose the pivot and to figure out the solution at the end. Remember, the basic variables are the variables corresponding to the columns of the identity matrix, right? Which in this case is basically I4, if you think about it, right? Because we have 4 rows. So the very first, it's very important to put the basic variables here on the left in the order 1, 0, 0, 0, 1, 0, and so on. So the first basic variable is S1. That's always the case in the beginning. The second basic variable is S2. The third basic variable is S3. And then the P is the one for the last basic variables. P will be always a basic variable. The initial simplex tableau always have this configuration. Now later on, the basic variables which will change after the pivoting operation. Remember the current values. The current values of the variables. For those who are basic variables, current values are on the right hand side. So S1 is 20, S2 is 24, S3 is 16, P is 0. All the other variables that are not in the basic variable list are assumed to be 0. So x1 0, x2 0, x3 0, and P is 0, I mentioned already. And again, remember, it pays off to actually plug in the x values into the objective function along the way to check to see that they are in agreement. So when you plug in these values into x1, x2, x3, you should get this value in, namely P equals 0 for the objective function. Again, this will change as you move on with the pivoting operation. All right, so let's do quickly another example. So let's see, suppose we want to maximize P equals x1 plus 2x2 plus 5x3. Subject to minus x1 plus 2x2 plus 3x3 greater than or equal to minus 10, 3x1 plus x2 minus x3 greater than or equal to minus 12, x1 positive, x2 positive, x3 positive. Notice in this case that the system is not given in the standard form because the inequalities are not less than or equal to something. So the first thing to do is to multiply all the constraints that are not in the standard form by minus 1. Switch the inequality signs. So it's going to be x1 minus 2x2 minus 3x3 less than or equal to 10, minus 3x1 minus x2 plus x3 less than or equal to 12, and then x1 positive, x2 positive, x3 positive. Check again, because now if you multiply by minus 1 and the right hand side is not positive, that means the problem cannot be written in the standard form and the whole algorithm that we learn right now doesn't apply. In this case, it is in the standard form now. So we can proceed like before to introduce the slack variables. So it's going to be x1 minus 2x2 minus 3x3 plus s1 equals 10. Minus 3x1 minus x2 plus x3 plus s2 equals 12. And that's it. We have only two constraints. And then in the objective function, move x1, x2, x3 on the left side. Okay, so now notice that the initial simplex tableau will have only 3 rows, simply because there are only 2 constraints to begin with. And because of that, we have only 2 slack variables. Okay, so the number of rows is dictated by the number of constraints. The number of columns is dictated by the number of variables as well. So just like before, let's write by column the coefficients of p. Again, 0, 0, 1. x1 will be 1 minus 3 minus 1. And then minus 2 minus 1 minus 2. x3 is minus 3, 1 minus 5. 1, 0, 0, 0, 1, 0. The right hand side 10, 12, and 0. Let's again isolate the last row, and the basic variables, just like before, corresponding to 1, 0, 0 is S1, corresponding to 0, 1, 0 is S2, and as always, P is always the last basic variable. And the current values will be S1 equals 10, S2 equals 12, P equals 0, X1 0, X2 0, X3 0. So with these examples in mind, I hope it's pretty clear how we move from a maximization problem in the standard form, how we change it to a system via the slack variables, how we write the initial simplex tableau, and finally, how we figure out the current variables. Now, in the next part of the lecture, I'm going to actually go over one more pivoting example, and that should be sufficient for 5.1 before we move on to the actual algorithm. So stay tuned. Okay, so in this last example, let's start with an initial simplex tableau. So let's start already with the simplex tableau. Basic variables p, x1, x2, x3, s1, s2, s3, and the right hand side. Right, and the columns are 0, 0, 0, 1, 1, 2, 3, minus 1, 2, minus 1, 2, and negative 2, 4, 1, 4, minus 3, and then the slack variables 1, 0, 0, 0, 0, 1, oops, 0, 1, 0, 0, 0, 0, 1, 0, and the right hand side, let's say, is 24, 32, 18, and 0. Okay, so that's the last row, and the basic variables are S1, S2, S3, and P. So as I said before, we're going to talk about in the next section how we choose the pivot. For now, take for granted that the pivot is equal to 3, that entry in the third row. And let's focus on the pivoting operation. So remember, pivoting operation basically consists in 2 steps. Divide pivot row by the pivot, and then create zeros above and below the pivot using the pivot row. So row operations, just like in the Gaussian elimination. With a little practice, you could do this in one step, but let's do it in two steps. And while you do these intermediate steps, the dividing the pivot by the pivot row by the, excuse me, the pivot row by the pivot, you don't have to bother to write the labels of the table. Do that at the end when you're done with the last portion of the algorithm. Okay, so everything is the same except the pivot row, which is divided by 3, right? So row 3 is going to be divided by 3. So the simplex tableau looks like this. Might be a useful idea to keep some distance between the entries so that you don't mismatch these entries in the wrong column. So let's pay attention here. Divide by 3. So 0, 1, 2 over 3, 4 over 3, 0 over 3, 0 over 3, 1 over 3, 18 over 3, which is 6. Circle again the pivot, which is now 1. And on the next step, let's close the matrix here so we can separate it from the rest. So we're going to do zeros above and below the pivot. So we're going to do minus row 3 plus row 1, and that will change row 1. Minus 2 row 3 plus row 2, and that's my new row 2. Row 3 plus row 4, and that'll be new row 4. Now you can, because this is basically the last, this is the simplex tableau after the pivoting operation. Now you can write the labels because you're going to need them, potentially. Again, once you get used to the process, you can skip these labelings, but don't do it until you actually get used to the whole process. Okay, and let's pay attention how these rows change. So minus row 3 plus row 1, so minus 0 plus 0, minus 1 plus 1, minus 2 over 3 plus 2. So minus 2 over 3 plus 2, I'm going to use this area for scratch paper. That's going to be 4 over 3. Let's see, yes, 0, 0, 4 over 3. Minus 4 over 3 plus 4. That's minus 4 plus 12 over 3. That's going to be 8 over 3. And then minus 0 plus 1 is 1. Minus 0 plus 0 is 0. Minus 1/3 plus 0 is minus 1/3. Minus 6 plus 24 makes it 18. Go slower and check with me these computations. You're going to have fractions that you cannot avoid. So that's the nature of the beast, basically. So let's do the second operation. Minus 2 row 3 plus row 2. 0, 0. Minus 2 times 2 over 3, that's minus 4 over 3 minus 1, makes it minus 7 over 3. And then minus 2 times 4 over 3, that's minus 8 over 3 plus 4. Minus 8 plus 12 over 3, that's 4 over 3. No? One second. So minus 8 over 3, what did I do here? Plus 1, I think I added the wrong entry here. All right, so minus 2 times 4 over 3 is minus 8 over 3 plus 1, and makes it minus 5 over 3. Minus 5 over 3. Sorry about that. All right, moving on. Minus 2 times 0 plus 0 is still 0. Minus 2 times 0 plus 1 is 1. Minus 2 times 1 over 3 plus 0 is minus 2 over 3. And then minus 2 times 6 plus 32 makes it 20. Pivot row stays the same. And then finally we add row 3 to the row 4. 0 plus 1, 0. 2 over 3 minus 2, that's minus 4 over 3. Again, go slow on these fractions if you need to. there's no point in rushing. 4 over 3 minus 3 minus 5 over 3. And I know I'm saying this, but I know for a fact that some of you probably still rush, but I'll do my duty to tell you what you should do, and then after that it's on you. So 0 plus 0 is 0, 0 plus 0 is 0, 1/3 plus 0 is 1 over 3, 6 plus 0 is 6. Because by the way, notice that, because right now, for example, when I went a little bit faster, I made a mistake, which I fixed it, because I always have to look back and double check. Everybody can make mistakes on these things. It's not a sign of, how can I put it, master of the algorithm. But since you need to actually solve these problems on paper, you just have to slow down, because if you introduce an error early, that error propagates, not to mention that it's hard for me to grade as well. So now pay attention to the basic variables. This will change, right? So S1 is still the basic variable. S2 is still the second basic variable. But notice now the column for 0, 0, 1, 0 shifted from S3. So prior it was S3. Now it became corresponding to X1. So this is what actually pivoting does, basically. I mean, it shifts these columns of the identity matrix from one column to another. And then the meaning of them in algorithm is essentially testing one of the corners, if you make the analogy with the graphical method. P always, like I said, remains the same basic variable always in its position. So because the basic variables changed, now the current values also changed. Not all of them, of course, but you have at least one change of the basic variables. So S1 is 18 still, S2 is 20, but now X1 is no longer 0. It is equal to 6 because it's a basic variable. P equals 6, and then everything else not in the basic variable list is assumed to be equal to 0. So again, pay attention to the values of x1, x2, x3 in relation to the objective function. Actually, forget about that because I didn't actually provide the objective function in this case. Although you can actually kind of figure out, well, let's write it down, because you can actually figure out that the objective function from the initial simplex tableau was p equals x1 plus 2x2 plus 3x3. So notice that the current values are in agreement, right? If I plug in 6 for the current value of p, 6 for x1, 0 for x2, and 0 for x3, indeed, you get the tree equality, right? So the current values should be consistent with the objective function. So as soon as you're comfortable with pivoting operation in the simplex tableau, the initial simplex tableau, then move on to 5.2, but not earlier than that. So I think that's it for today.